Now we come to the end of the questions. So this is question number 90th, and which is related to an organic chemistry, a very simple question based on a simple logic called as dehydrohalogenation. Now similar type of question is already asked wherein we have tertiary butyl, sodium tertiary butoxide in the previous question. So if you would have been able to solve that, you already know that this is nothing but dehydrohalogenation, which is basically an elimination reaction. Right. So what exactly is going to happen here? So this is sodium tertiary butoxide, and this is going to be a strong base, right? So this strong base would allow dehydrohalogenation or elimination. So normally we are going to discuss something about the beta elimination, right? So here is the bromine. So this is the alpha carbon, this is the beta carbon, and in beta carbon there are 3 hydrogens available here. So this H and Br goes in the form of HBr, and then you will be able to get an alkene like this, correct? So you get an alkene in this case. So there was a Br initially. Now it's going to be, the Br is removed and there is a double bond over here. So I'm just going to write it this way because I have already put one bond over here, right? So this is nothing but CH2, okay, and there are 2 hydrogens. Okay, there is 1 hydrogen, sorry. Okay, so yeah, O is connected to C and there is 1 hydrogen over here as well, correct? And that's not removed definitely. So this is an alkene, and you already know that alkenes decolorize bromine water, right? So this decolorizes bromine water. So I'll write this decolorizes bromine water. So this is the first one. Now let's move, so this is second one. So second one cannot be the option because they have given which of the following fails to decolorize. So if you have a look over here, so this is alpha carbon, this is beta carbon, and this beta carbon has a hydrogen, right? So this can undergo dehydrohalogenation, as a result of which you could get a compound, you could get an alkene, correct? So you will be having something like this, and then there will be a phenyl ring over here. Correct. So this is again an alkene. So this will decolorize the bromine water. So this gives a positive Br2 water test. Correct. And then let's move on to this part. This is alpha carbon, this is beta carbon, and this is beta carbon as well. There are 3 hydrogen atoms over here. So HBr would be released, and then you would be left out with this particular compound. Okay. So you have a alternate single and double bond. Then there is a double bond O, and then you would be having is this same? No, there is a carbonyl group over here, correct? So this is going to be something like this. So this again has a double bond. So again this would give a bromine water test. So it's an obvious thing that this particular compound is the answer, right? But just have a look. So this is alpha carbon. There is no beta carbon, so no beta hydrogen, correct? So that means it will not form any alkene. So if it does not form any alkene, it will not decolorize. It will not decolorize bromine water. Okay, so it won't decolorize bromine water. So this is the reason you could simply say that this will fail to decolorize the bromine water. Even alkynes do that, but in this case even alkynes cannot be formed, right? So the correct answer for this particular question is option number 4. Okay, so this is the answer to the 90th and the final question. So I hope you had a very nice time solving the JEE exam as well as listening to all the solutions, and I hope you have enjoyed it properly. And for more updates, kindly share, comment or subscribe to our videos.